Hi and Assalamualaikum. Today we will do a present to defend our proposal. But first I will introduce our team members. Our team member consists of 3 people including me. So my name is Muhammad Al-Fariduddin bin Ahmad, which matrix number 01DEM20F10 and 64. Our other team member is Muhammad Aiman Ikhwan bin Aziz, matrix number 01DEM20F10 and 62. And Farizul Azrin bin Omar, matrix number 01DEM20F10 and 61. Without any further, let's start with the presentation. This is the title of our project, Automatic Parcel Receiver. To give the glimpse of our project, I will explain a little about our project. So, as the name suggests, the project is invented for receiving the parcel that have been delivered to us automatically without our presence. So how do we get an idea to making this project? So at first we discuss what is the trending in our society, and we get an idea that online shopping is something that everybody in our society are doing right now. So what is online shopping? Online shopping is a form of electronic commerce which allows consumers to directly buy goods or service from a seller over the internet using a web browser or a mobile app. Nowadays, we literally can have everything that we want by the tip of our fingers. And of course, we need money to have the everything. This is because we literally can do online shopping with any device that we have, such as smartphone, desktop computer, or tablet. It also will save our time because just by clicking on the item that we want, the item will be delivered directly to the address that we set. How will our project will be any help to people who love online shopping? We have recognized some of the problem when we do online shopping, and the project will help to solve the problem. So what is the problem that occur when we do online shopping? For starter, the problem that always happen during online shopping is there is no receiver when the item is delivered. This will lead to the people who do the delivery will leave the parcel near our house, either at the top of mailbox or in front of the gate house. By this, the item might get damaged by weather such as rain and heavy winding, or animals such as cat, dog and bird. Secondly is the courier have to deal with the customer complaint when the parcel is damaged or anything. This is unavoidable since the one that leave the parcel outside the customer house is the delivery man. But we can 100% put the blame on the courier side since there is not much option for them. Thirdly is people who always busy and not available at weekdays during working hours. This is specified for those who live alone and always not available at home since they will be working during the delivery time. Last but not least is people who have issues or difficulties to receive the parcel. They are available at home, but due to some reason, they can go out and receive their parcel. For example, people who have been quarantined because they have been tested positive for COVID-19. So to conclude it, this project is mainly to help people who having issues to receive their parcel and also to help the courier to deliver the parcel safely. This is the objective for the project. At the end of the project, we need to make sure that the system can be controlled from the long distance via Blink software. Other than that is, we are able to design automatic parcel receiver based on PLC. Most importantly is we are able to test the project and make sure it working properly and can receive the parcel without damaging the parcel. So we have done some survey for our project to see people opinion on what aspect or criteria on our project that we need to focus on. So the criteria is listed here, which is easy to operate, low maintenance cost, low price, safety guarantee, high durability, corrosion resistance, environmental friendly, good appearance, high reliability, and lastly efficiency. This is the result of the survey. We have ranked the criteria from our survey question based on their importance to our project, and we see that safety guarantee is appear to be first on the rank as people are keen to make sure that the project is safe to use before they buy it, followed by the efficiency of the project, which comes second. The maintenance of the cost need to be low are ranked third. At fourth, we have a high durability. Rank 5 is affordable price. 6 is easy to operate, which means the project must not be complicated. 7 is environmental friendly, as people do not want to disturb other people while using this project. 8 and 9 is high durability and good appearance, and the criteria that comes last is corrosion resistance.
Hello, my name is Muhammad Aiman Ikhwan, and I will continue presenting from my friend, which is Muhammad Al Fariduddin. So, for this slide, it shows the data we made to fulfill the needs of the client. We establish a house of quality to determine which feature or technical standard are the most significant in meeting the requirements. So, for the second column from the table, we have the customer requirement, which is low price, easy to operate, low maintenance cost, safety guarantee, high durability, corrosion resistant, environmentally friendly, good appearance, high reliability, and also efficiency. So at the top of the column, the table, we have the engineering requirement, which is manufacturing process, design, type of actuator, controller, safety specification, electronic sensor, type of conveyor, project size, cost, and also type of material. Okay, by increasing the importance score from the survey questionnaire and their relationship with the technical specification by 1, 3, and 9, which is 1 indicate for weak, 3 for moderate, and 9 for strong score, we discover that we need to focus on the controller of our product based on the calculation we perform in the house of quality matrix. Okay, the next is the concept generation. Okay, now is the concept generation from our teams. We use the flowchart to determine what is the concept. So, first, after the parcel is reached to our home, the courier will drop the parcel at the drop point and push the push button to run or start the process. Okay, the process start after we push the push button, and that give the order to PLC to run the cylinder by the sequence A minus, B plus, B minus, A plus, which is and cylinder A will retract first, and then cylinder B is extend, and then cylinder B also retract, and cylinder A um, extend again, and turn the conveyor on simultaneously when the cylinder is at the A minus sequence, which is A minus, which is the cylinder A is retract. Then when parcel pass the conveyor, it will go through the IR sensor, and that give the signal to a microcontroller to turn the door open in the box. We also put the IR sensor to make a system more safety, which is the IR sensor will send the signal to the Wi-Fi module, and we get the notification at our phone. After that, we create the morphology chart to know what the component for every design used. From morphology chart we create, we will expand our idea on how we will design our product, and also we can know what is the necessary component should have in our product, such as what type of conveyor is relevant to use, or what type of PLC controller that's suitable in our product, and so on. Here is our sketch of the concept, and this is the sketch for design 1, 2, and 3. And this is the sketch of the concept for design 4, 5, and 6. And from this design, we can know how our product will look like, and we will try to explain one by one.
This is the first concept design in CAD drawing. As we can see, this design uses a pneumatic actuator and roller conveyor. This is the bill of material for this concept and the exploder view. Which exploder view function, we can see how this concept is designed more clearly. It used 10 cylinders in total, which 4 connected to the 2 stage each to lift the stage, and others 2 is connected to the main body. and second body of the project to move the parcel to conveyor and to move the parcel to get in the box. It uses 16 rollers that have been wrapped with conveyor belt for transferring system and have storage box at the end of the project design to keep the parcel safe. This is the orthographic drawing for each part of the project. This is the main body. We can see how the roller is connected with the body, and we can get an idea on how it will move the parcel from the stage to the conveyor. This is the second body. The hole at the bottom of the body is for the cylinder, where in this situation, it is different from the main body, where the cylinder is connected directly to the body. But in this case, the body of the cylinder will be outside and only the piston will enter inside the body only when it extends. This is the detailed drawing of the three components, which is the storage box, cylinder and roller. This is the roller where will be connected with second body, and the reason I made an orthographic drawing for this cylinder is it have different measurement from the other 9. This is the conveyor belt that will be wrapped with the 16 rollers. And last but not least, the stage for this project, where the parcel will be put and the stage will be go upwards and downwards with the 4 cylinder as its actuator. This is concept design 2. For this concept, we have the same actuator as design 1, which is pneumatic, but instead of using roller conveyor to transfer the parcel, I use hanger conveyor to transfer the parcel. The hanger conveyor will be carry the parcel from main body to the stage using the net basket that have been hanged to the rail slide. Same like design 1, we will look on the build of the material of design 2. We have the main body that have been connected with 2 cylinders, 2 railway that will be connected to wall or something that can fit the railway position, 1 net basket to carry the parcel, and 2 rope that act as connector between railway and the net basket. As for the stage, it will have 4 cylinders, which the first 2 will act to move the stage upwards and the other 2 to move the stage to get 45-degree position, so the parcel can be removed from the net basket to the storage box at the end of the design. Now we will see each of the part in orthographic drawing. This is the main body, so the design is made to get the stage of the body can be lift only to 45 degree to the right. So for it to be moved 45 degree to the right, we will use cylinder that will be controlled using pneumatic. This is the stage. So as for the stage, there are 2 phases. In the first phase, the cylinder that have been connected to the stage will lift the stage upwards, so the net basket will have a flat surface. On the second phase, the 2 other cylinder that will be mounted separately from the stage will act like the cylinder for the main body, which to move the stage upward to the right only until 45 degree, so the parcel can be removed to the box. This is the net basket. The net basket will be built so it will not stretch when it carries something, so the basket will not crash with the stage. This is cylinder 1 and cylinder 2. The cylinder on the left side is to move the main body as 45 degree upward and downward. On the other hand, the cylinder on the left side is for the stage. This is the storage box and the rope that will be connected to the railway and the net basket. And on the last drawing, we have the railway that will determine how far the net basket can go.
For the third design, I decided to use a rail path and belt conveyor for our product because I thought we can reduce the cost by using the 2 conveyor. And for this design, our product used the door type for the drop point, and for the storage box, it just the storage box without any sensor inside it. This is the bill of material and the exploded view of my design, which consists of body, storage box, conveyor belt, conveyor roller, metal basket, roller metal basket, drop point part 1, drop point part 2, and drop point part 3. This is the prediction dimension of my product, and this shows the dimension of the body of my products. And this is the roller conveyor or idler roller for belt conveyor, and the next is the conveyor dimension, and at the bottom is the roller metal basket dimension. Okay, for this is the dimension for all the components at the drop point. Okay, this is the last, and this is the dimension of the metal basket. Is it from metal as it the name given? For design 4, I'm using two conveyor. First conveyor is long and the second is a bit smaller. Then in this design, I'm using the pneumatic function. The first is vertical and the second is horizontal side. The drop point, it is controlled by pneumatic. And for the storage box, I designed as a small type. And in the fourth design, I'm adding the actuator sensor for safety and can notify us if the parcel was reached at the storage box. Okay, the next is the build of the material for design 4 and the exploded view, which is consists of body, horizontal cylinder, vertical cylinder, roller, small conveyor, belt conveyor, small belt conveyor, storage box, sensor actuator, drop point, and roller main conveyor. Okay, in this slide, this is the dimension of the body, and this have a two-part separated. Okay, this is the storage box. Is it smaller than design 3? And the next is the drop point, and at the bottom is the sensor actuator to actuate the sensor. And this slide shows the dimension of the dead part. Afterward, this is the diagram and the dimension for the pneumatic cylinder for vertical one and use longer than the second one pneumatic type. Okay, and last is the dimension for conveyor belt, long and small, and between that is the roller for the conveyor belt, which idler roller for the conveyor.
My name is Farazul Azramil Omar, and I will continue this presentation. So this is concept CAD design 5. This design is quite simple. The parcel will through the door and it will move with a belt conveyor and through the safe place. For the bill of material, the first one is door, and the second is the conveyor, and the third is legs. So this is the full dimension of the design. As you can see, the conveyor is the 150-degree with 20 centimeter long, and this is the dimension of the conveyor belt and the idler roller conveyor. Okay, this is the concept CAD design 6. This is actually like the hanging conveyor. The parcel will put in the box at the conveyor and will move to the drop point safely. The bill of material for this design is the first is the hanging conveyor, the second one is the box, and the third one is the pole. So this is the full dimension for the CAD drawing design 6. As you can see, its height is 70 and its width is 144. So this is the product 3 for our project. The first one is system. Our project use the pneumatic system and conveyor system. The second one is actuator. We use infrared sensor. We use Wi-Fi module. We use 5 two-way DCV and relay. For the housing, we got the body, we got the drop point and the storage box. For the controller, we use two controllers, which is the PLC on-run controller and Arduino microcontroller.
Okay, for this is the project block diagram, and it will be like this. The input is the push button, which is when it push, it will trigger the pneumatic system, conveyor system, and the microcontroller simultaneously. After the parcel is receivable and the push button is pushed, the pneumatic system will make their sequence, which is A minus, then actuate by IR sensor, then make a B plus signal, then do same like B plus and B minus and A plus. Okay, next is the parcel will be pushed by cylinder B and reach the conveyor system. After that, microcontroller function to control all the sensor from IR sensor into the mobile phone, which is that it our output of the system. Okay, this is the circuit of our project for pneumatic system that we create using Automation Studio. Okay, for the sequence A minus, B plus, B minus, and A plus. And here we have the circuit diagram for the external electrical circuit that for safety. And at the bottom, we create the light as an indicator. Green shows for the processing running, and blue for the rectifier to convert AC to DC to trigger the microcontroller, and yellow for the conveyor, and the white is indicate for system to at the shutdown state. Okay, this is the simulation of the pneumatic circuit that we create using Automation Studio. We push the start button and A minus, B plus, B minus, and A plus again. And at the bottom shows the light to indicate our process. And we place 2 times.
So for the suggested fabrication, the first one is drilling. Drilling is used to assembling our housing such as a body, drop point, storage box, and anything else. The second one is soldering. Soldering with our own solder sets to attach the wire and component for the circuit. Okay, now is suggested testing. The first one is the load test. Load test is the way to us to test the pneumatic system. To determine load of pneumatic system can carry to avoid system failure or overload. The second one is the pressure test. The pressure test is to measure using pressure gauge and indicate the pressure inside the pneumatic system in bar in gauge pressure. Second one is the measuring the condition of air that is specified by the force that the air would exert when at rest on a unit area. Then the last one is to indicate if have any leakage at our pneumatic tube. So the third one is the multimeter. The multimeter is a kind of meter which is usually voltage across any two terminals. Current flowing through any component and resistance is measured. Multimeter is used to measure voltage and current that is suitable to our system. Used to test all electrical components at this project, such as sensor, microcontroller, and anything else.
For the estimated price for the concept design 1, the total will be RM 1721 and 8 cents. This is understanding because on the first concept we use 10 cylinders, and of course since we have 10 cylinders we will need 10 DCV. These two items is the reason why the price is so high. adding with some other components such as pneumatic tube set, and electronic component like DC motor, relays, sensors, and Arduino. As for the second concept, we have total of Rm 1418 and 90 cent. It doesn't have much different from the total price of concept 1. The only reason why it's a little lower than concept 1 is because it used 8 cylinders in DCV instead of 10. It also have almost the same component like design concept 1, which is pneumatic tube, DC motor, relays, sensor, and Arduino. The only difference is the type of conveyor set that we need to buy.
Okay, this is the estimated cost for design 3. And it consists, first is conveyor belt, mini linear rail, toggle switch, DC motor, screw M 2.510 mm, Arduino Uno, infrared sensor, via SDS 901, hydroller conveyor, jump wire set, solder iron set, screwdriver set, relay egg channel. So the total for this estimate cost is 461 and 90 cents. Okay, and this is estimated cost for design 4, which is consists double active cylinder, 5 to 8 DCV double solenoid, pneumatic tube, DC motor, conveyor belt, Arduino Uno, infrared sensor, screw M 2.5, 10 mm, hydroller conveyor, jump wire set, solder iron set, toggle switch, Wi-Fi module ESP8266, relay egg channel, rectifier SDS901, and total estimate cost for design 4 is 559 ringgit.
So this is the estimated cost for my design, which is design 5. The first one is DC motor. The quantity is 2 and it costs 40 ringgit. The second one is conveyor belt and quantity is 1. The cost is 95 ringgit. The idle roller conveyor, I use 2 and it costs 29.75 ringgit. And the fourth one is Arduino Uno. I use 1 and the cost is 45 ringgit. And next is the infrared sensor. I'm used to infrared sensor and it costs 10 ringgit. And next is jump wire set. I use 1 and it costs only 5 ringgit. And the last one is a Wi-Fi module ESP8266. I using 1 only and it costs 28 ringgit. So the total estimated cost for design 5 is Rm 252 ringgit and 75 cents. So this is the estimated cost for design 6. The first one is box, quantity 1, cost 30 ringgit. Second one is hanger, quantity 1, cost 52 ringgit. The third one is roller, quantity 1, it costs 43 ringgit. The fourth one is Arduino Uno, is quantity 1 and it costs 45 ringgit. The fifth one is jumper wire sets, quantity 1, costs 5 ringgit. And next is metal pole, quantity 3, it costs 200 ringgit. The next one is the infrared sensor, quantity is 2, it costs 10 ringgit. And the last one is Wi-Fi module ESP8266 and it costs 28 ringgit. So the total estimated cost for this design is 413 ringgit. So this is the bar chart for every design. So the design one, the simple design, the design one get 3 marks. Low cost, it got 2 marks. Model size, 2 marks. Efficiency of notification, 1 marks. Safety, 4 marks. And time operation parcel completely received is 3 marks. So the total is 15. For design 2, the simple design, it got 2 marks. Low cost 3 marks, model size 3 marks, efficiency of notification 3 marks, safety 2 marks, time operation parcel completely received is 3 marks. So for the design 3, the simple design it got 3 marks, low cost got 2 marks, the model size got 3 marks, efficiency of notification got 3 marks, safety got 3 marks, time operation parcel completely received got 4 marks, and the total is 18. So for the design 4, the simple design is 4 marks, low cost it got 3 marks, the model size it got 2 marks, efficiency of notification it got 5 marks, safety it got 4 marks, time operation parcel completely received is 3 marks, and the total is 21 marks. And for the design 5, the simple design it got 5 marks, low cost it got 5 marks, model size it got 1 marks, efficiency of notification it got 2 marks, safety it got 1 marks, and time operation parcel completely received is 5 marks. So the total is 19. So final design is design 6. For the simple design it got 4 marks, and the low cost it got 4 marks, model size it got 2 marks, efficiency of notification it got 3 marks, safety it got 1 marks, and time operation parcel completely received it got 4 marks, and the total it will be 18. So for the objective, the project aims to first design a parcel receiver conveyor system that can work using pneumatic system and PLC. Second one is simulate the project using software. And the third one is build and test the conveyor to observe the response of the sensor, pneumatic movement and speed of the conveyor. So this is our Gantt chart from week 1 until week 14. That's all our presentation group for today, and we want to say thank you for all of you. Thank you.